On this problem, we have the integral from 0 to pi over 2 of sine cubed x dx. And we're going to split it up into 4 subintervals to estimate the value of the integral. Okay, so the first thing it asks us to do is sketch a graph of the integrand on the interval of integration, which for us is going to be from 0 to pi over 2. So how I go about doing that, I have a TI 84, type it in into y equals, and you can graph it. It will look like this. That's not that helpful for us. So let's change our window. And the first thing I'm going to do is I'm going to say zoom, and I'm going to go to the trig window. That sometimes helps you because it creates a window that's specifically with trig functions. This is probably pi over 2, pi, and so on. That helps sometimes. But for us, we really don't care about anything that happens left of 0, so I'll put 0. And we really don't care about anything that happens to the right of pi over 2, so that's what I'll put for my x max. And for the scale, we'll figure this out later in the problem, but given that we are on 0 to 2 pi, or 0 to pi over 2 rather, and we're on 4 subintervals, then each one of those intervals is a fourth of pi over 2, which is pi over 8. So I'm going to make my x-axis have little tick marks at every pi over 8. And we'll get more into that in a minute. Going to go from 0 to 1 on this. You can do trial and error till you figure that out, but that gives us our best graph to look at this. Okay, so we can see it's a continuously increasing function on that interval. Okay, so that gives us, and we can sketch that if you want. So this is pi over 8, pi over 4, 3 pi over 8, and pi over 2, which is the end of our interval. And you can see that gives us 4 subintervals. I'll show you how I calculate that in a second. But you got basically this graph that starts at 0, and then it starts increasing until it gets up here and it maxes out. Okay. All right, so that's the graph. And then it says calculate x and the grid points x sub 0, x sub 1, blah, blah, blah. So that's basically asking us to calculate where we got these. So where I got those is I took the interval of 0 to pi over 2, and I did pi over 2 minus 0, and I divided by the number of subintervals that it asked. It asked for 4 subintervals. So that's what we have, and that's where we get the pi over 8. Okay, so that's where the pi over 8. This is 2 pi over 8, which reduces to pi over 4, 3 pi over 8, and 4 pi over 8, which reduces to pi over 2. Okay, so our intervals are going to be x sub 0 is equal to 0. X sub 1 is equal to pi over 8. X sub 2 is equal to pi over 4. X sub 3 is equal to 3 pi over 8. And x sub 4 is equal to pi over 2. Okay, so those are our little tick marks there. Okay, and C says calculate the left and right Riemann sums for the given interval. Okay, so a Riemann sum, basically what we're asked to do here is we're going to estimate this using rectangles. Okay, so for a left Riemann sum, I'll draw this graph again, but for a left sum, we start on the left most of the interval, and we find the graph there, and we go to the right. So you can see the graph there is at 0. We can calculate that in a minute. You can see the graph's at 0, so that first rectangle is actually just a line, so it's going to be 0. And then we start here at the graph and go to the right, so that one's a non-zero graph. And then here on this left subinterval, create one where the height is on the left. And then for our last one, here. Okay, so you can see based on that graph, so this is what we're going to be calculating the area of. You can see that it's less than the actual area of the graph. Now let me graph this thing again real quick, as close as I can get to that graph up there. And I'm going to draw a right Riemann sum, a graphical representation of a right Riemann sum. So it starts at 0, goes up a little bit, and this may not be exact, but Close enough. Okay, so now for a right Riemann sum, you start from the right point. So you find the graph here, and then you travel back left. Start from the right point, hit the graph, travel back left. And as you can see, this appears to be giving an overestimate of the area. Okay, so there are some other ways you can do the midpoint that kind of averages those two, or you could just add both of your answers up at the end and divide by 2, and it'll probably be better than either the right or the left Riemann sum. But that gives us what they look like. Now I need to actually figure them out. Okay, so first of all, how far is each one of my subintervals? Well, they're pi over 8, right? This is pi over 8, this is pi over 8, this is pi over 8 on both of them. So for the left sum, I'm going to multiply every one of my function values by their base length, which they all happen to be pi over 8. Okay, so I'm going to multiply pi over 8 times f of pi over 8 plus pi over 8 times f of pi over 4 plus pi over 8. I messed this one up. This is actually a right Riemann sum. So since I've already done that much of it, let's do the right Riemann sum. I'll let you know where my mistake was, is that I didn't start from the left. I took my first value and made it pi over 8. Okay, my first value should have actually been 0 for the left Riemann sum, because the height of this rectangle starts here, and that's a 0 height. So it should have been f of 0, f of pi over 8, f of pi over 4, and f of 3 pi over 8. So I'm actually doing a right Riemann sum, so I'll continue that. F of 3 pi over 8 and plus pi over 8 times f of the last one, which was pi over 2. Okay, I'll do that. I'll get that answer in a second. I'll leave a little equal sign there. Let's go ahead and actually write down the left one this time, since I screwed it up that time. So it's still pi over 8, but this time we're multiplying it by the left side. Okay, so that is f of 0 plus pi over 8 times f of pi over 8 plus pi over 8 times f of pi over 4 plus pi over 8 times f of, let's see, what would that be? This is not, I screwed that up again. So that's 3 pi over 8. Okay, so that's the left sum. So apologize for missing earlier in the video naming this as 3 pi over 4. That's 3 pi over 8. Okay, so the leftmost sum would be 0, pi over 8, pi over 4, 3 pi over 8. Those are the values that we need in the function. The right one would be f of pi over 8, f of pi over 4, f of 3 pi over 8, f of pi over 2. Okay, so we've got them both written down. Now we need the answers. That's where the calculator comes in. Okay, so let's go to our calculator. Put it over here so you can still see what I'm doing here. Okay, so we've got, let's do the right one first. Okay, so what I'm going to do to figure this out is first I'm going to factor out the pi over 8s out of all of them, so I don't have to keep writing it. They all have one, so I'll put it out front. So here's the pi over 8. Pi over 8. Okay, and I'm doing the right sum first. I'm doing this one. So that's going to be vars, y vars, function, y1, and then I open parentheses and put in pi over 8. That, since I've already typed the function into the y equals, did it earlier when I was graphing this thing, then y1 represents y1 in the graph. It represents this. Okay, sine cubed. Okay, so I'll do it again for pi over 4. So vars, y vars, enter, enter. And then open parentheses and type in a pi over 4 plus, let's put the plus sign in there. Don't want to miss that. Plus, and now vars, y vars function, open parentheses, my next one is 3 pi over 8. Plus, and then finally, pi over 2. And then close your parentheses around all of them, because remember we're multiplying by pi over 8. So if you don't close parentheses, it might screw something up. And then hit enter. and you get that your right Riemann sum is 0.863. Okay, now finding the other one, once you've got it all already typed in, finding the other one's actually a lot easier, because you notice that most of them are the same. The only one different between the right and the left Riemann sum, the right has this term in it, but this one doesn't have that. The left has this term in it, but the right one doesn't have that. But the other three are the same. So if I just hit second enter in the calculator, it'll bring up what I just typed in, and I get rid of the one that has a pi over 2 and replace it with a 0. So it's this one that has it. So put a 0 and delete any extra stuff there. And then just hit enter again, and we get our answer for the other one. So the left Riemann sum is 0.471. Okay, so that is it, but let me quickly show you how to average, because the average is going to be typically better than either one of the two. So if you want to average them, which you might be asked to do in another problem, you just add up those two answers. So 0.4705228463 plus 0.86322 1928. I use all the decimals that I can because I want to get as accurate an answer as possible. And then enter, divide by 2 because we're averaging them. So your average is 0.66 and round it to 7. Okay, so that is the best answer out of those two. Out of those, well, better than either one of those two.